Hello, and welcome to another lesson from Level Up Mathematics. In today's lesson, we will be solving literal equations. Before we get started, let's look at a definition. A literal equation is an equation with more than one variable and can be rearranged using inverse operations to solve for a specific variable. So as an example, if you had the formula distance equals rate times time, this is a literal equation because it has three variables. It has more than one variable. We could rewrite this expression to solve for time, and that would be distance divided by the rate. Same exact equation, just rearranged to be solved for a different variable. Let's look at a couple of examples. In problem A, we have A plus 2 is equal to the 4, and the directions say to solve the equation for A. So if I want to get A by itself, I would simply subtract 2. I'm using inverse operations here to isolate the A. So 2 minus 2 would zero out, and 4 minus 2 is 2. So when we isolate the A, we get A equals 2. Now look at problem B. Here we have a very, very similar problem. It says A plus 2 is equal to C. So I want to isolate the A. I want to get it by itself. So I have to subtract 2 from both sides. So A, this would zero out, is equal to, now for C and 2, these are not like terms, so we can't combine them. So we would just write down C minus 2. So again, we isolated the A. We got the A all by itself. All right, problem C. We have A plus B is equal to C, and I want to isolate the A, and I want to solve for A. So I would subtract the B, and we're left with A, these terms would zero out, equals C minus B. All right, example D. We have 2 times A is equal to 6. Now, in this problem, we're not going to subtract the 2, but rather, because we're using inverse operations, the opposite of multiplying by 2 is dividing by 2. So when I divide by 2, this 2 and this 2 will cancel out. So A would equal 6 divided by 2, which is 3. All right, problem E. A times B equals 6. If I want to solve for A, I need to remove the B. So I'll divide both sides by B. So B and B would cancel out, and I'm left with A equals 6 divided by B. All right, problem F. A times B is equal to C. I want to solve for A, so I'll divide both sides by B. This B will cancel with this B, and A would equal C divided by B. All right, now here's a question. Which equations in example 1 were literal equations? And what do you notice about all the answers to literal equations? So pause the video, think about the question, and write down your answer. All right, welcome back. Hopefully you recognize that the literal equations were in example B, C, E, and F. And the answers to literal equations, let's see. How do I want to write this? Let's see. The answers to literal equations all contained variables. All right, example 2. It says solve each equation for the specified variable. Now, in example 1, we were solving for a every time. In example 2, we will be solving for a different variable in each problem. So in problem A, it says A equals the length times the width, and they want us to solve for W. So this is just the area formula for a rectangle. Now, what I like to do is rearrange this equation so that what you're solving for is on the left. So I'm going to rewrite this as length times width equals A. I haven't really done anything. All I did was flip-flop this so that the variable I want to solve for, W, is on the left side of the equation. Now, I highly recommend if you have a highlighter to highlight the variable you're solving for, or you could circle it. It's easy to forget sometimes which variable you're trying to isolate. So I'm just going to highlight the W to remind myself I want to isolate W. So I need to use inverse operations to remove any term that's attached to the W in some way. So here we have length times width equals area. So the opposite of times is divide. So I'm going to divide both sides by L. So this L would cancel this L, and that would leave me W. All right, I met my goal. I isolated the W. And A divided by L, nothing we can do to simplify that. So that's our final answer. All right. In problem B, it says we have M is equal to C minus S. Solve for C. Okay, so I want to put the variable that I'm trying to solve for on the left. So I'll simply rearrange this equation so that C minus S is on the left and M is on the right. Okay. All right, now let me highlight what we're trying to isolate. We're trying to isolate the C. So that means I have to get rid of the S. All right, so the opposite of minus S is plus S. So I'm adding S to both sides. So C is equal to M plus S. Right. In problem C, we have I equals P times R times T. This is a very famous formula for simple interest, but they want us to solve for T. They want us to solve for T. So I'm going to rearrange this so that the T is on the left side and the I is on the right side. Now again, I'm going to highlight it because I want to remove everything from the T. So this is P times R times T. And the way we remove multiplication is through division. So I want to divide both sides by P times R. P times R. So the P cancels with the P, the R cancels with the R, and leaves me T. And then we have I, or interest, divided by the principal times the rate. All right, problem D. D equals M divided by V, and they want us to solve for M. So I'm going to rewrite this so that the M is on the left side and the D is on the right side. All right. Now I want to get the M by itself. So I have to remove the V. So we need to use inverse operations. So this is M divided by V. And the inverse operation for division is multiplication. So I'm going to multiply both sides by V. So when I do that, this V would cancel with this V, leaving me M. And this would be D times V. All right. In problem D, we have area, or A, equals 1/2 times the base times the height. This is a very famous formula for the area of a triangle. We're trying to solve for the letter H. Now, I'm also going to rewrite this as area equals base times height divided by 2, because that's the same thing as 1/2 base times height. It's just another way of writing the same thing. And I'm going to put that on the left side. So base times height divided by 2 equals A, And again, let me highlight what we're trying to isolate. We're trying to isolate the h. All right. Now, whenever there's a fraction, you want to remove the fraction first. So the opposite of dividing by 2 is multiplying by 2. Multiply by 2. So be sure to multiply by 2 on both sides. So this 2 would cancel with this 2, leaving me base times height, or BH. And over here, a times 2 is simply 2a. All right. Again, let me highlight what we're solving for. We're solving for h. So I want to isolate the h, which means I need to remove the b. So I'll divide both sides by b to get h equals 2 times the area, or 2a, divided by the base. 2a divided by the base. All right, in problem D, we have volume equals 1/3 times the base times the height. Solve for b. All right, pause the video and try this problem on your own. All right, welcome back. Now, I rewrote this problem like this. BH divided by 3 is equal to V. Then I multiplied both sides by 3. And the reason I did that is because I always want to remove the fractions as my first step. So cancel, cancel. BH equals 3V. Highlight what I'm trying to solve for. And then I divided by H. So B is equal to 3V divided by H. Check your answer with mine. If you need to, pause the video and correct your work. All right, example 3. Solve for the specified variable. In problem A, we have k equals mv squared divided by 2, and they want us to solve for m. So I'm going to rewrite this as mv squared divided by 2 equals k. I'm going to highlight what we're trying to solve for. So I need to remove the v squared and the 2. But remember, we always get rid of fractions first. So I'll multiply the left side by 2, and I'll multiply the right side by 2. So this 2 would cancel with this 2, leaving me mv squared equals 2k. And then I want to highlight what I'm trying to isolate. So I'm trying to get the m by itself. So I want to divide both sides by v squared. So when I do that, this v squared cancels with this v squared. So m equals 2k divided by v squared. All right, problem B. We have a equals b plus c divided by d, and we're solving for b. So I'm going to rewrite this as b plus c over d is equal to a. All right, so when we have a fraction, remember our first step is to eliminate that fraction. So I want to multiply both sides by the denominator. So multiply both sides by d. So this d would cancel with this d, leaving me b plus c equals AD. And let me highlight what I'm trying to solve for. So I want to get the b by itself. So the opposite of plus c is minus c. So b equals AD minus c. All right, problem C. We have 4x plus 2y is equal to 8, and they want us to solve for y. Now, the y is already on the left side, so I do not need to rearrange this formula. All right, what I need to do is get rid of the 4x and the 2. So I'll start by getting rid of the 4x, and that will, let me put an x there, this will zero out, and I'm left with 2y equals 8 minus 4x. Now, Whatever you do, do not combine those two terms because the 8 does not have an x. Leave it separate. Okay. Now, again, let me highlight what we're trying to isolate. So this is 2 times y equals 8 minus 4x. So the opposite of times is divide. So I want to divide this side by 2 and this side by 2. So y equals 8 minus 4x divided by 2. Now, this one, you could take this one a step further. And I'll show you another way you can write it. Your teacher may even require you to go to the next step. So let me just show you. I totally, for my students, I'll accept this first way. But you could divide each of those terms, the 8 and the 4x, by 2. So 8 divided by 2 is 4. And negative 4x divided by 2 is negative 2x. So this is another way you could write your answer. Let me put an or there, okay? All right, problem D. Negative 3x minus 2y is equal to 8, and we're solving for y. Now, the y is already on the left side. So we need to get rid of the negative 3x and the negative 2. All right, so to get rid of the negative 3x, we'll add 3x to both sides. That would be step 1. We always want to remove our addition and subtraction first, then remove the multiplication or division. So this would zero out, and we'd be left with negative 2y equals 8 plus 3x. Now we're trying to solve for y. In other words, we want to isolate the y. So the opposite of multiplying by negative 2 is dividing by negative 2. So this would be y equals 8 plus 3x divided by negative 2. All right, problem E is going to be similar, except this time we're solving for x. So we have the equation 2x minus 6y equals negative 12. We are trying to isolate the x this time, not the y, okay? So I want to remove the negative 6y and the 2. All right, so I'll remove the negative 6y first by adding 6y. So that gives me 2x. This would zero out, equals negative 12 plus 6. Oh, not 6x, 6y, excuse me. Why did I say x? That should be 6y. All right, now we'll divide both sides by 2. So x equals negative 12 plus 6y divided by 2. If you want to simplify that a little further, negative 12 divided by 2 is negative 6, and 6y divided by 2 is 3y. So I would accept either one of these answers. Because both the terms in the numerator were able to divide by 2, it was pretty easy to simplify it. Okay. All right, problem F. We have negative 3x plus 4y equals negative 24. Solve for x. Pause the video and try this problem on your own. All right, welcome back. Let's see how you did. For my first step, I subtracted the 4y from both sides. So negative 3x, this zeroed out, is equal to negative 24 minus 4y. Then I divided both sides by negative 3. So this cancels with this and left me x equals. And this side we have negative 24 minus 4y divided by negative 3. Now, you could simplify this a little bit more. I'll show you what you could get. You don't have to. Negative 24 divided by negative 3 is positive 8. And a negative 4y divided by negative 3 would be positive 4/3 y. Either answer is correct. All right. And that concludes today's lesson, solving literal equations for specified variables.